In this problem, we need to find the values of t when the particle is at rest, which means the velocity is 0. The velocity is given by the equation 3t squared minus 16. T plus 5 equals 0. Factorizing the quadratic expression gives 3t minus 1 multiplied by t minus 5. Solving this, we find two values for t, 1 over 3 and 5. Next, we need to determine the range of values of t when the acceleration is greater than 0. Acceleration is the derivative of velocity with respect to time, which is 6t minus 16. We solve the inequality. 6t minus 16 is greater than 0. This gives t greater than 8 over 3. Finally, we calculate the distance traveled by the particle in the interval between 1 and 4. Distance is found by integrating velocity with respect to time. The integration gives t cubed minus 8t squared plus 5t, evaluated between the limits of 1 and 4. Substituting t equals 4 and t equals 1 into the expression and simplifying gives negative 42. The magnitude of this value, 42 meters, is the distance traveled in the interval between 1 and 4.